are now pleased to welcome Sergio Savaresi, professor at Politecnico di Milano, as second keynote speaker at our 2022 Zero Prototype Summit. His presentation will cover recent advances in autonomous racing. He will discuss various autonomous or hybrid motorsport formats, with a particular focus on their potential impact on the development of fully autonomous vehicles for public road use.
Okay, thank you for being here, despite the weather, or maybe thanks to the weather. Still British weather, English weather. Anyway, today we'd like to share with you some thoughts and something I've learned, or I believe I learned, from a recent experience about a new discipline, which is autonomous motorsport. A few words about where I come from. I'm from Politecnico di Milano. Politecnico, you probably know, is a very high-ranked university. We are number 13 in the world. And I am the founder of a big research group. It's called MOVE. Called MOVE. I founded 20 years ago, and it's a big group for the academic standard, which is fully devoted to develop technologies for control in vehicle systems. Let me switch to, let's say, autonomous motorsport, and let's say artificial intelligence in motorsport. So first of all, let me share just three very general slides. It's something very, I'd say, obvious. You all know this stuff, but just to have a prologue to my presentation. So you know that we are transitioning from the classical type of mobility, which is big, fossil fuel, personal ownership, human-driven cars, to the new world of small and light, electric, shared, and autonomous cars. But what I would like to stress, I think it's really important, that there is one of these mega trends, which is a catalyzer. And the catalyzer is the autonomous car. The autonomous car, most of the people still don't realize that the autonomous car will be the catalyzer and the booster, let me say the big bang, for the servitization of the mobility, and the servitization will boost, will make the second wave of the electrification and the size reduction. So this is the real, let's say, big bang and catalyzer of the new mobility. Overall, we can simply say that the autonomous car challenge, another click. No other click, thank you. The autonomous car challenge is by far the most important technology trend. It will provide a complete revolution of the mobility model and induce major changes in the structure of the automotive industries, as you clearly know. It's a big challenge from the technology point of view. Let's say it's very difficult to understand when level 5 will be ready, but something like 10 years, 15 years is a reasonable assumption. Let's say driving a car is probably the most challenging human task to be robotized. So it's a real gigantic challenge that the automotive industry will face in the next year. Let's go to motorsport. In this slide, this is a very conceptual slide. Try to say a very simple concept. So motorsport, let's say the top one, let's say Formula 1, typically is ahead of let's say normal cars, production cars. This is true for engine, materials, aerodynamics, simulation, everything, except one, which is the automatic control, robotization, artificial intelligence. You can see that the yellow line is motorsport. At the beginning, it was above the green line, which is the, let's say, everyday car. But it was, many times, it was taken down again and banned. Motivation is obvious, because we want to keep the importance of the human pilot. And that's the obvious reason. Today, there is an issue. The issue is that, from one side, the automotive industry is going massively to the development of the autonomous car. It's going to be, let's say, 80% of the effort of the new technology, the development of the autonomous car. And at the same time, this technology is the only one missing in motorsport. So there is this contradiction which is already quite big. So there is already a big gap on this technology, and the gap is diverging. So there is an issue, because it's quite, let's say, embarrassing that the top motorsport is going away from the main direction of the automotive industry. Because of this, this year there was the birth of the autonomous racing. Autonomous racing has, let's say, a specific, let's say, birthday, which is the 7th of January of this year. And it was in Las Vegas, within the CES, the first ever competition, fully autonomous, multi-agent, really multi-agent, head-to-head, really high speed. It was, let's say, very challenging competition that received a lot of attention from the media. So it was really the birth of this new discipline. I would like to quote a second initiative in autonomous motorsport, which is Roborace. Roborace will start the first real championship, the season 1 next year, but did already some let's say, experiments, some test season. I would like to mention the Roborace initiative, because they first introduced the combination, the simultaneous combination of physical cars and metaverse. At this point, the typical question that I get is, what is the interesting format for autonomous motorsport? In order to understand the most appealing format, you can make a game, an exercise. You can take the car driver, that can be human or artificial intelligence, the car that can be real car or simulated, and you can make all the permutations. So let's make this game. Classic motorsport, 2 humans, 2 real cars. Classic gaming, 2 humans, 2 simulated cars. What we did in the Indy Autonomous Challenge was a simulation race, 2 AI, 2 simulated car, and the real race, 2 artificial intelligence with 2 real cars. Question: is this the nice format, the really appealing format? Well, probably no. Probably no. In the long run, can be boring. My bet, and it's a general opinion, that the real target will be this one. Will be the human against the artificial intelligence. So 2 real cars, 1 human, 1 artificial intelligence. Notice that it's interesting that in between there is this format, which is the human drives a real car, the AI drives a simulated car. Notice that this is an in-between, less risky, of course, but requires a technology, which is an enabling technology, which is a AR helmet. So the real driver, so the human driver on the real car, should be able to see, these are some simulation, we are doing some research activity in this sense, should be able to see the simulated car driven by the AI driver. This will be it's a mix, and probably there will be some interesting, say, direction in this sense. Change the slide. Thank you. 3 quick remarks. The first, it's easy. Notice that among all the sports, all the top sports, motorsport is the only one which is where realistically you can mix the human and the AI. It's nearly impossible. Team sports, also single sport, we are 50 years let's say, before we can really think about a humanoid robot against a player like this. In motorsport can be done because a motorsport driver is, let me say, 95% a brain. So it's essentially is an intelligence. It's a very much developed intelligence of a human. The second remark is a classical question I get. Is it going to end like Deep Blue versus Kasparov? The story, it's easy. At some point, Deep Blue won. From that point on, end of the story. So the computer always can beat a human in chess. notice that it's going to be a totally different story. So chess is a perfect playground for a computer. It's just a big combination, finite combination of possibilities. So driving a car at race level is an incredibly higher complexity. So my bet, my prediction is that I expect a comparable performance in 10 years, 8 to 10 years, not before than that. I expect AI can consistently be better than a human in, let's say, 30, 40 years. But my feeling is that if we think about what I call the augmented human, so if we can give to the human some additional perception or augmented perception, probably this match will be balanced maybe forever. So think about this. It's a really complex task, nothing to do with a chess game. The final comment is very technical, but I think you can fully understand the comment, and it's about the curve of development of a car. Let me say a performance car, high-performance car. So we all know that the very first stage of the development of the car is getting more and more digital and simulation-based. So today we have heard a lot of comments and speeches in the same direction. So this part is taking more and more space. Then there is the real car with a human tester. But there is the final part, let me call the last 5%, that from my point of view is a no man's land. In the sense that at some point, there are some oscillation. Why the oscillation? Because the human typically cannot be perfectly consistent. So the repeatability of the human is not 100%. So there is a sort of indetermination principle. It's not Heisenberg, but at some point, change the car induces the changes in the driver behavior. So the measure affects the measurement. So I believe that this room, this part, is the perfect place where an artificial intelligent driver can have a major role. So my bet is that in the future, this line will go more and more ahead, and the final part will be occupied by an artificial intelligent driver that we have seen, I've touched, let's say, in practice, has a huge advantage of a perfect repeatability. So you can change something on the car, the artificial intelligent driver can make the same lap exactly in the same way. You can clearly see what is the effect of a variation of the car on the performance. And most probably, the human will be out of this loop, and its role, her role, will be to give the performance index. So it will be always very important, but as a performance index developer, not in the development stage. So my bet is that it will be all simulation plus artificial intelligence. Some snapshot of preliminary conclusion. So motorsport will quickly follow the autonomous car trend. Why? Because it cannot do in another way. So in some way, motorsport must include this technology in this discipline. Most likely, long-term direction is human versus artificial intelligence. It's the most appealing, most challenging, most fascinating direction. And we can probably expect some sort of hybridization between real and the metaverse. So today, the metaverse is the most important keyword, so we can expect something in that direction. So let me now tell you something about the future of what we are doing. What we are doing, and at the end of this, what we are doing, you will see something very closely related with VUI-grade technology. Our project has a name. We call the name Ascari. It's an acronym, but at the same time, it's the name of the most famous Italian driver. In this project, we have two directions. So the first is motorsport. In the motorsport, and we say, we have a dream, I have a dream, it's a bit naive dream, but just to give the direction, is to develop a top driver competing in, 2030, 2035 competition. I personally bet, I'm convinced that in 10 years from now, 15 years from now, in the top competition, Indy cars, Formula One, the team will be forced to hire a human and an artificial intelligence driver. So the dream is to be there. What we have done, Ascari did well, started well. So we won the simulation race. We were third at Indianapolis. It was a downgraded competition, just solo laps. We had, let's say, an issue, hardware issue with the power unit, and we won the Las Vegas competition. Recently, we got the world record of speed. It was a very fascinating venue. So it was not the most difficult from a technical point of view, but the venue was fantastic, the landing facility of the space shuttle. And we are continuing our journey in our journey in the Indy Autonomous Challenge. This year, the Indy Autonomous Challenge will have this plan, most probably one race in Texas and again at the CES. 2023, we will move to road course circuits, and we will go ahead along this competition. Okay, what we are doing for production cars, this is for racing. What we are doing as a research team for production cars, two ambitious projects. So the first one is, we call it active driver assistant on track. So you can see in this slide, very simplified idea. So the very simplified idea is to provide, so we call it also the virtual fence mode. So the idea is to provide a protection for the driver, for the non-professional driver, but in a completely different way. So I like to say this is not ABS, this is not electronic stability control. I like to use this image. So this is a traditional electronic assistant. So you are holding the hands of the baby. In this case, you are just monitoring the baby, ready to catch it. So it's the difference from an internal assistant to an external assistant. It's very complex. You need to make some prediction and to intervene in a prediction way. But we are at a very good stage of development. I have some patents about that. We are almost ready to go on track on real cars with this technology. The second project is a long-term project, is the development of a small slice of technology. Of course, we are not developing the full stack of technology for everyday cars. So the idea is that the emergency module, so the module able to deal in very critical situation, is the most obvious outcome, is the most obvious lesson learned from motorsport, which is high speed, super fast reaction, critical condition, limit of the friction. Let me conclude. I would like to conclude my presentation. This is maybe the most important part of my presentation by anticipating you some concepts about a new, let me say, revolutionary, let me boast something with this revolutionary methodology for state estimation and control. We call it the simulator in the loop or sim loop approach. So the general concept is this one. Typically, the simulator for control design is used before, let's say offline, let me say, for development, is not used in production, is not used on board. Question, is it possible to use the simulator, so the car real time, for instance, for state estimation and for control, but on board real time in production? The answer is yes, and it's extremely useful. State estimation. In state estimation, you know that the classical approach is the state observer or Kalman filter. The idea is that you put here a model, a simplified model, and you make some feedback correction. Typically, what you use are simplified models. It's a list of simplified models. Question, is it possible to use the same architecture, let's say the state observer, but plugging in here directly the full simulator, the full model? Yes, it's possible. We did it. It's complicated. It's complicated. It requires a simulator able to stop and refresh the state vector at every sampling time. It's not an easy task, but it's feasible. We did it. And we need also some machine learning approach to optimize the feedback gain. We did it. We tested on real data in real time, and you can see here some result, some preliminary result. So immediately we got better result than, let's say, a traditional, let's say, production-grade estimator, like in speed and in size leap. Notice that the big benefit is not necessarily a higher quality. But the real benefit is that with one simulator, you can estimate everything. You don't have to split in many different pieces. What about control? In control, you know that typically there are many steps. You start designing the controller on a simple model, then you calibrate on the simulator, and then you go on the real car and you make calibration. Question, is it possible to use directly the simulator on the car? Again, the answer is yes. Very interesting. You can use an internal model control framework. The idea is that you make a feedback real time on the car, on the simulator. You open loop give the input to the vehicle, and you make a correction. Again, very interesting. Immediately we got a very important result. You can see here a difference between a classical MPC and an MPC with this architecture. It's clearly visible that you get immediately significant advantages using this technology. So what we are doing is to apply this technology on our racing car. You have seen today probably our booth, our stand with this architecture. I'm not going to enter in the details. I'm running out of time. But anyway, we are using all the framework, so including the hardware. You can see there the auto-hook concurrent hardware in a complete simulation environment. And that's it. You can see, let's say, some videos, and that's the first video we got on the Las Vegas Motor Speedway, the first simulation result, car real time, and WorldSim. So we hope we are sure this can help us a lot to go ahead in this very challenging motorsport adventure. Thank you for your attention.